Okay, cool. I think we are live. We are recording. Let me just go into the slideshow. Let's see if that helps the viewing experience. By the way, can you see my screen? Yeah, you can see my screen. Okay, perfect. All right.
Yes, yes. Yes, we are seeing your screen.
Awesome, awesome. Well, thank you for inviting me to give a little bit of a workshop here. Today I'll be presenting the AI native blockchain ecosystem that we're building at Metis. To first start off, I worked as the DevX lead at Metis, and before that, I worked as the let's say integrations lead. So I helped onboard a lot of projects. I worked in this space for about 5 years. So very, very familiar with how everything works and interoperates. So right now, the idea or the big mind share, the big topic is AI. One of the big things related to AI is how does this fit into the things, the day-to-day things that we think of when it comes to blockchains even, or just day-to-day operations, even before we go into the blockchain part. So AI is essentially just an extension of yourself, allows you to multiply your productivity. You would be able to do things that you would otherwise not be able to do yourself. So we've seen a lot of like vibe coding, vibe designing, vibe project managing. Like there's definitely a lot of posts that decouple the need for having specific skill sets. Now there are some challenges. One of those is the information. Where does it come from? So whenever I am going into ChatGPT, I am essentially trusting OpenAI's model and the information that it gives to me. And that information can be changed, manipulated, and as a result, certain inaccuracies can be there. So throughout the life cycle, there's like a whole pipeline that the information goes through. And understanding the way that the data is handled, especially when dealing with these different types of providers, you need a clarity for this. In addition, when you're executing models, let's say I'm hosting a version of OpenAI, or sorry, I'm hosting a version of one of the AI models. How do I know that AI model was executed and not some other AI model? How do I know that the data that I've presented to the AI model is actually being used within this execution and not something else? Now, today, we likely don't think about these things because these AI does a good enough job. But when we think about financial transactions, or whenever we think of these AI agents that are operating autonomously, how can we guarantee that they are, in fact, operating autonomously and not being influenced by a third party? Now let's take a little dive into agents. So agents, basically, the large language model is a vehicle, and it's essentially the infrastructure that is used to perform an action that the agent wants. And the data is the navigation system. So it tells the driver, it tells the agent where to go. And the agent is the driver. And then they use the LLM with the data to perform a set action, as well as different tools or any type of extensions from that. But essentially, this whole pipeline is the agent relies on both the LLM and the data in order to perform an action. So if the LLM is swapped or the data is manipulated, we can't guarantee that the agent will do what it's meant to. And this is the key point, because if we can't guarantee that the agent would do a certain execution, then it could 100% be manipulated. And as an example, AI XBT is a automated account, and the results of AI XBT, basically it takes information from the outside world, summarizes it using an AI model, and then posts the result on Twitter for everyone to then look at, react to, and take that information. There is no way currently. Well, no, there is a way. There is a way that you can make sure that the AI agent does perform the intended task. And because if, let's say, an AI agent, even though it has that automated tag right here, it has this automated, technically speaking, if you don't have a guarantee that the AI agent isn't manipulated in some way. You also don't have a guarantee that the AI agent is using a certain model to base their conclusions off of. And again, that leads into me having, let's say, the username and password of the AI XPT or another popular agent service. And as a result, I can make any tweet that can then cause people to potentially ape into something that the AI told me to do it. And as a result, tons of manipulation can occur. So can I prove that an agent is using a specific LLM and that the data is correct? So there's different ways that you can do this. One of the ways is the one that's used actually today by a lot of these agent services is a trusted execution environment, or a TEE. And this TEE guarantees from a hardware standpoint that the execution of the program was not manipulated. And because you have a hardware guarantee, that basically means that you can trust that the execution wasn't manipulated. But of course, that comes from hardware guarantees. As a result, you need to use very specific hardware that a very limited providers can produce. And that hardware does get expensive. So it's also that cost structure. But right now, that's probably the most used form of ways that you can guarantee execution. The other way that you can guarantee that an execution is happening is with zero-knowledge proofs. Now, zero-knowledge proofs are notoriously slow, and that also requires a lot of processing power as well. And with this, we have to rely on dedicated machines to run the execution as well as generate a proof. And that also introduces another problem, which is latency, which you have to wait for that proof to sufficiently execute, and then only then will it actually be guaranteed that the action did in fact happen. Now, the third way, the on-chain native way, has been, let's say, not focused on too much. Why? Because the on-chain native is allegedly actually expensive, slow, as well as it is public, right? With trusted execution environments and zero-knowledge proofs, those are private. And with on-chain, there's public. But there's ways that you can combine these different types of mechanisms and ensure that the data that also remains private, even if you're operating in a blockchain environment. So the main two, the expensive and slow part, has been a very big dissuader from people to create these on-chain AI agents. Now we come in with Hyperion. Hyperion is the next generation blockchain built specifically for AI agents. And we include different types of functionality that allows you to natively to run these AI models natively on-chain, which then gives you the flexibility of parallel transactions, just-in-time and ahead-of-time compilation, as well as AI native precompiles. So the intent of this is to make this on-chain verifiability and execution of the different types of data to be open and transparent. So let's go over a quick demo. We're going to take a look at the Metis SDK. And with that, I am using this DeepSeek R1 distill over here to run some operation. Let me just go in and let me just change my screen to be over here. Yeah, the Metis SDK. Okay, so very quickly, I'll just demo some of the examples here. So we have, let me just increase the size. Oh, too big. So over here, we have the ahead of time compiler. Now, again, if you don't know ahead of time, just in time, the idea of this is flexibility, right? I can go in and perform operations that are tailored for speed versus portability. And then this would give me more options to build more programs that can leverage this AI functionality. I want to just demonstrate the AI functions right now. So let's go into the inference. So over here, very small relatively to the rest of the applications. If you take a look at like node.rs, you have tons of code. But over here at the inference, what I'm basically doing is I go in and take a specific chain config. So right now it's trying to tell me to go to Cancun, but no, this is the Prague. I think that was it's a new EVM version. And then we have the ability to send essentially the data to the model. And then we're able to execute the result of this to a specific precompile address. Actually, taking a look at this, let me just dive a little bit deeper to take a look at what exactly is it doing. It's sending to the address of tons of zeros plus a 999 at the end, and it's actually taking a local model that I've taken. So I've shown you the exact model that I used on the Hugging Face, and then essentially it's running the model, the GGUF, through the blockchain, and as a result, I am able to run a specific type of operation, which in this case is the tell me a joke. So let's run this very quickly. For the specific examples, we have the inference right here. So we'll do example inference, and I think it'll ask me that it's like it requires the features, so that you don't have to. Oh, sorry. Oh, did I leave the call? No, okay, I didn't leave the call. All right, let me just. I think someone was calling me on my other device. So let me just copy this guy right here. There we go. All right, features inference, and let's add a here. And over here, it'll compile and then run the code, and then it gives me the results. Sure, here is a light-hearted joke for you. Why don't skeletons fight each other? Because they don't have the guts. Okay, bad joke, but you see how this works. So again, all of this executed on-chain, and it used the specific model that I told it to. which was present in here, and it did so again on chain, verifiable, and the goal is that we can do a lot more of these types of operations using this native type of integration. We can layer additional functions, but apart from that, that's basically the showcase that I want to go over. Definitely take a look at the Metis SDK is the let's say the tool for building this whole interop, essentially, or the connector between blockchain and AI for the purpose of verifiable computation. So yeah, any questions here? Or I do have to actually. I have an AMA right after this in my Twitter. Yeah, I have an AMA on Twitter, and as a result, I can answer long form any questions that you might have regarding the Metis SDK and like why, and expand on any more details. So if anyone here has any questions, let me know. I can definitely help answer, or if you don't, then that's okay. You know where to find me. You have my Telegram.
Yeah. Thank you, Pafe, for bringing this for Crossfire builders. It's really go a long way for all our builders in the space right now. I think we have a lot of builders here presently. If there is any question, please can just quickly ask your questions from so that before the said he has another space after this. Is there any question from anyone?
Yeah, I actually had.
Okay.
Yeah, so hi Pavel, hi team. So I had this question. So what is the size of AI model that Metis SDK supports? Is there any config for that?
So we've tested it out with the 1.5 billion parameter size, but since the it should operate with larger models as well. I believe the gas limit for that is 2 million for that, but I don't think it reaches that much. I need to do a little bit more testing to see if it can support like huge models, but likely the model context window is small enough that you can do a lot of these types of interactions.
Okay, that answers.
Okay.
Yeah.
I think thank you, Pafe. Is there any other person with any question?
I think we can wrap up here, and then if anybody else has any questions after they watch the recorded session, for those who couldn't be here today, this is a more intimate group, and we have a lot of time schedules that are different. But thank you so much, Pavel, for joining us today. It's been great having you. You're in the chat now, so if anybody has any replies when we post the video, we'll be sure to let you know. Thank you for sharing more about Metis to us. And we hope to maybe collaborate with you again soon. And good luck with your AMA.
Awesome. Thank you, Haley, and thank you, Solio, for the invite. I'll see you guys in the chats.
Thanks so much. Talk soon.
All right. Bye-bye.
Talk soon. Bye-bye.